Open your book to page 106. Okay, and let's go to example 6. Example 6a, you have a sine theta equal to square root of 3 over 2. And it says find the least positive theta in degree and radian measure, okay, for this one. So to find the least angle, you always want to see if you can get it in quadrant 1. The quadrant 1 would be your first choice, then your quadrant 2, quadrant 3, and quadrant 4. Okay. So over here, so this one, you want to check, see if you can do quadrant 1, and answer is yes. So it's square root of 3 over 2. So square root of 3 over 2, so this is 1. So from here you can see that theta for the degree is going to equal to 60 degrees. And if it's radian, it's going to be pi over 3. Okay. So you need to draw the triangle based on the ratio it's giving, and then you again choose quadrant 1 first if you can, then just go down the quadrant. Okay, let's go to B. You have cosine theta equal to -1 over square root of 2. Okay. So you can try quadrant 1. Well, quadrant 1 is positive, so you cannot do quadrant 1. So now you go to quadrant 2. It's -1 over square root of 2. So this one, yes. So -1 square root of 2. So from here you can see that this is 1. So this is going to be 45 degrees. So 45 degrees is your alpha. So that means your theta would be 135 degrees. Right? This is 180, right? So this is 90. So 90. So 180 minus 45 give you 135. And for the radian, this would be 3 pi over 4. Because here's 0, so 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay. And so that's it. So that's how you find the least angle. Now let's look at the next part on page 106. It talks about periodic functions. Periodic function means the function go through periods that it will give you back to the same position. Okay. So all the trig functions are periodic. So if you go on page 107, okay, it shows you that b equal to sine x is equal to sine of x plus 2 pi. Now what it's saying is that if you have an angle, let's say this is angle x. Now x is your angle now, it's not a horizontal. So here's your angle x, okay? And so this part of here, the vertical, the b is sine x, okay? So here's your angle. Now sine of x plus 2 pi means you want to increase the angle by 2 pi. So what it's saying is that here's your angle x and you want to increase by 2 pi means you go around the circle 1 time. And so you're going to end up in the exact same location, and therefore they are equal. Okay? And same thing with cosine. So cosine x equal to cosine of x plus 2 pi. It's because of here is your cosine of x, right? So that's your cosine x. And if you increase the angle by 2 pi, right? So if you increase the angle by 2 pi, you go around the circle 1 time, you're going to end up at exactly the same place. So at this angle, you have the same cosine. Okay. So let's go over example 7. Example 7a, it says if cosine of x equal to -0.0315. Now you don't have to know exactly where that is. You can just draw it so you can have something to look at. So cosine is negative. Let's imagine that. That's cosine of x. Okay. So cosine of x, this is -0.0315. So for part A, you have cosine of x plus 2 pi. Okay. So what it's saying is that you want to go around the circle 1 time. You plot, this is your angle, and you want to add 2 pi. Okay. So here's your angle, and you add 2 pi means you go around the circle 1 time. You're going to have the same cosine. Okay. So again, this is going to be equal to -0.0315. Again, when you add 2 pi means you go around the circle 1 time. So you're going to end up with exactly the same length. Okay, for part B, you have cosine of x minus 2 pi. Well, cosine of x minus 2 pi means you go around the circle 1 time by going in the clockwise direction. So you're over here and you're going negative direction. So again, you're going to end up exactly the same place. So you end up at the same place, you're going to have the same value, same horizontal value. So again, it's going to be the same. Okay. Now you go to C. you have cosine of x plus 18 pi. So what it's saying is when you plus 18 pi means you go around the circle 9 times. So here's your x, right? Here's your cosine of, here's your angle x, and you're going to add 18 pi means you go around the circle 9 times, and you're going to end up at exactly same place. And since you're exactly same place, the cosine of that, the horizontal, the length would be exactly the same. Okay, so all these are exactly the same value. Now if you go to D, part D, you have cosine of x minus 34 pi. So what it's saying is that you're looking for the value of cosine that minus 34 pi means you go the negative direction 17 times because each circle is 2 pi. So negative 34 pi means you're going around the circle 17 times. And again, when you go around negative 34 pi, you go around 17 times, you're going to end up exactly the same place. And if you end up exactly the same place, you're going to have exactly the same value. Okay. Okay, now let's go to page 108. Use the functions, identities. So page 108, there are a whole bunch of identities in blue. Okay, as you know from before, when you have a sine is equal to let's say A over C. Let's say you have this triangle over here. So that's your A. Okay, let's do this. Let's do A, B, C. So sine would be B over C, right? And cosecant we know from people, just flip it over, right? It would be C over B, right? But notice they're reciprocal of each other. So from this, that's how we get this cosecant equal to 1 over sine theta, because they're reciprocal of each other. And so same thing, secant of theta would be equal to 1 over cosine, because they're just reciprocal of each other. And the tangent theta is going to be equal to B over A, and B, this is equal to B over C over A over C, right? If you multiply divide both the top and the bottom by C, so this is going to be equal to sine over cosine. And also you can see that, right? The B is up and down, right? It's vertical over horizontal, right? And sine is vertical over horizontal. It's the same, right? So that's what that is. And cotangent is reciprocal of that. But instead of using 1 over tangent, instead of flip this over, you want to flip this over. So it becomes equal to cosine over sine. Okay. So those are your kind of the function that you should kind of be familiar with. Okay, the next one, you have the sine of negative x equal to negative sine of x. So the way to figure out if it's going to be the same or the opposite is by drawing pictures. Notice you have cosine of negative x equal to cosine of x. Okay, so notice these are opposite, these are the same. So if you don't remember, all you have to do is draw a picture. Okay, so here's your angle x. Okay, and so here's your angle x, and then the sine x is right over here. Okay, so this is positive right over here. Okay. Now when you do the negative x, okay, so you have to go opposite direction, right? So here's your negative x. Okay, let's put angle here, negative x. So you can see that in this case, here's your sine of negative x. Okay. So you can see they're opposite. That's why they have to have opposite. Right. Now when you're doing the cosine, so again, here's your angle x. So cosine is right over here. Okay, so that's your cosine of x. Now, if you go opposite direction, over here you go this way, right? That's your negative x angle, right? And again, here's your cosine over here. Right, that's your cosine of. Here's your cosine of negative x. Okay. So notice that they are the same, right? They have the same length. That's why they are equal. Okay? Whereas over here the sine, they are opposite, so that's why they are opposite. So if you don't remember, all you have to do is draw the angle x and negative angle x, and see their parts, see they are the same or opposite. If they're opposite, then they will have opposite sign. Over here, if you draw the angle x, and you draw that, and you draw the negative angle x, and compare their length, they are the same, therefore they will have the same sign. Okay. Now let's go and do the tangent. So notice you got, the tangent, you have the tangent of negative x equal to negative tangent of x. Okay. So you just, all you have to do is draw your picture, right? So you can let your angle x, right? Remember now, x is an angle now, okay? Okay. It's less confusing if they use theta, but in the book they use x, so you got to how to deal with it. So here's your angle x, so tangent, so that's your tangent x, right? Remember tangent is a slope, right? And over here, if you draw the negative x, right? So here's your tangent. So notice they're not the same, they are opposite. The slope will be opposite. That's why they are opposite. So you can use, all you have to just draw the angle x, negative angle x, and compare their part. If they're opposite, they are opposite. If they are same, then they are the same. Over here, they are the opposite, that's why they are opposite. So that's how you kind of remember it. Okay. Now let's go to page 109. You have the identity, you have the sine square x plus cosine square x equal to 1. So from here, right, this is based on Pythagorean theorem. Okay. So if this is 1, then the vertical would be the sine x, and the horizontal would be cosine x. Okay. Remember, sine is vertical, cosine is horizontal. So based on Pythagorean theorem, right, a squared plus b squared equal to c squared, right? So you can let your a squared plus b squared equal to c squared. And that's where they come from, okay, from your right triangle. Okay, now let's go to example 8. Example 8 is to simplify the expression using all the identities. So you got a, you got sine squared plus cosine squared x over tangent x. Now when you try to simplify, what you want to try to do is try to make everything into sine and cosine if possible. Okay. So sine squared plus cosine squared from here we know is equal to 1. So this is 1. And actually this one you don't even have to do anything with the tangent, because you got 1 over tangent, this will equal to cotangent x. Okay, so this one you don't even have to change that into sine and cosine. But most of the time you want to try to change into sine and cosine if you can. Okay. Now let's go to b. You have sine of negative x over cosine of negative x. Okay, so sine over cosine equal to tangent. So this is equal to tangent of negative x. Okay. Again, sine over cosine is tangent. Now tangent of negative x, this will equal to negative tangent of x. Right? We did this a little bit earlier, right? From here. Okay. Again, if you don't remember, just go and draw the picture and see if they're the same or opposite. That's how you can figure it out. Okay, let's go to let's go and do match problem 8 on page 109. So for A, you have 1 minus cosine square x over sine cube x. So from here, if you notice the sine square x plus cosine square x equal to 1, right? So if you minus cosine square x from both sides, then you get sine square x equal to 1 minus cosine square x. Okay? So you have to, whenever you see the square, you got to think about the Pythagorean identity. So from the top, you're going to get sine square x. On the bottom, you're going to get sine cube x. Right? This is already sine, so you don't have to do anything to it. So when you cancel out, you're going to get 1 over sine of x, and 1 over sine is cosecant x. Okay, and that's it. Now let's do B. You have tangent of negative x and cosine of negative x. So if you're not sure what to do, all you have to do is just make everything to sine and cosine. So tangent is sine over cosine. So this will be sine of, and whatever you have in here, that's what you're going to put in parentheses, right? So sine over cosine and this one would be cosine of negative x. Okay? And notice this would cancel out. So you have sine of negative x, and from what we learned earlier, this will equal to negative sine of x.